Good morning, class. Today we are learning about a molecular absorption spectroscopy. Spectroscopic method of analysis involves the measurements of intensity and wavelength of radiation that is either observed or transmitted. Absorption spectroscopy is most frequently used in the estimation of molecules and so spectroscopy. Number one, we have ultraviolet or visible spectroscopy. Number two, we have infrared spectroscopy. And number three, we have atomic absorption spectroscopy. It deals with infrared region of electromagnetic spectra. It covers a range of techniques, mostly based on absorption spectroscopy. Then we look at the principles of IR. The IR spectroscopy exploit the fact that the molecules observe specific frequencies that as characteristics of their structure. The absorption matches the frequency of the bond or the group that vibrates. The energy is determined by the shape of molecular potential energy, mass of the atoms, and vibronic IR. We have the IR source, we have the sample compartment that has the reference and the sample. We have the chopper, we have the monochromator, and finally we have the IR atomic absorption spectroscopy, that is AAS, thus proved itself to be the most powerful instrumental technique for the quantitative determination of trace elements in liquids. Principle of atomic absorption spectroscopy. The absorption of energy by ground state atoms in gaseous state form the basis of AAS. When the solution containing metallic species is introduced into a flame, the vapor of that metallic species will be obtained. Some of the metal atoms may be raised to energy levels sufficiently higher to emit the characteristic radiation of the metal. A large percentage of the metal atoms remain in non-emitting ground state. In AAS, the element is not excited in the flame, but it is merely dissociated from its chemical bonds and placed in an unexcited or ground state. This is to mean that the atom is at a lower energy level in which it is capable of absorbing radiation at a very narrow bandwidth corresponding to its own diagram of the atomic absorption spectroscopy that consists of the following. We have the hollow cathode lamp, we have the chopper, we have the flame that consists of the oxidant, the sample and the fuel, we have the monochromator, detector, amplifier, and the readout device. And that marks the end of our lessons today. Have a nice day.